This video is on Unit 6, Exponential and Logarithmic Functions, Chapter 12, Exponential and Log Functions, and Lesson number 1, Intro to Logs, or Logarithms, log for short. What is a logarithm? A logarithm, or log, is another way to write exponents. In log form, we have log base b of a equals x. So this right here is read log base b of a equals x. That little b is what we call a subscript. So it's at the bottom, it's smaller than the log and the a, it's written smaller and it's written below. So log base b of a equals x. Now that's the logarithmic form. Log form can be written in exponential form. In exponential form, you have a base. The b that's the base of the log is the base of the exponent. The exponent is the answer to the log is equal a. So b to the x is equal to a. You will need to know how to change from log form to exponent form and exponent form to log form. If you can remember that the base is always the base. What I mean by that is the base of the log is also the base on the exponent. And the exponent is the answer to the log. So in this first section, it says write each equation in exponential form. The first one says log base 3 of 9 equals 2. So again, the base on the log is the base of the exponent. The exponent is what the log is equal to the 9. And that makes sense. Once you get it written in exponent form, it's going to make sense. Log form is just a different way of writing exponents. Number 2, for example, the base is 6. We write that 6 to the third is equal to 216. And you could even check that in your calculator. 6 to the third power is 216. 7, for number 3, 7 to the 0 power is equal to 1. This is a property. When we write it in exponent form, log to the power of 7 to the power of 0 is equal to 1. Anything to the 0 power is 1. So when we take the log of 1, the answer is always going to be 0. And that's a property that we'll get to later. On number 4, 2 to the 4th power is equal to 16. Number 5 would be read 4 to the negative 2 is equal to 1/16, which we get these negative exponents, and if you think back to the previous chapters, negative exponents are going to create fractions because we end up having to flip. And then number 6, 9 to the 3/2 power is equal to 27. Now that one is, that exponent of 3/2 is going to involve a radical, and that was that chapter that we had on radical equations. The next section is write each equation in log form. So now we're going to go from exponent form back to log. So log, the base on the exponent is 14, so the base on the log is 14. So log base 14 of 196 is equal to, the exponent is always the answer to the log. Again, number 8, log base 3 of 81 equals the exponent. Number 9, log base 12 of 12 equals the exponent. Number 10, log base 36 of 6 is equal to, the exponent is 1/2. Last 2, number 11, log base 2 of 1/8 is equal to, the exponent is negative 3. And number 12, log base 8 of 16 is equal to, the exponent is 4/3. So converting from log form to exponent form and exponent form to log form is just something that you guys are going to have to memorize the process on. Common log. A logarithm with a base 10 is called a common common logarithm, and can be written without the base. So log base 10 of x is normally just written log of x. So this is another one of those things that is understood. When there is no base, it's an understood 10. And before I move forward, I would like to point out that on your graphing calculator, if you find the number 7 and look to the left, that is your basic log, your common log. So that's where that log on the calculator is the common log. If it has a different base, it's a different spot. So the directions here on evaluating logs is to use your knowledge of exponents to evaluate the following logarithms. So we're going to try to do some of these in our head. So I'm going to put an equals x on number 13. And I want you to rewrite this in exponent form. So 7 to the x power is equal to 49. So ask yourself, 7 to what power is equal to 49? Well, 7 squared is 49, so x would be equal to 2. And this is how we can evaluate logs using our mental math. So again, on number 14, that process is 3 to what power is equal to 27? Well, I know that 3 times 3 is 9, and 9 times 3 is 27, so that means x is equal to 3. 3 to the third power is equal to 27. Now, look at number 15. It doesn't have a base on it, which means it has an understood base of 10 to what power is equal to 100. Well, I know that 10 times 10 is 100, so that means that's 10 squared. So x is equal to 2. On number 16, as soon as I see the 1, I know what my answer is, but I'm going to walk you through this. We're going to rewrite 12 to what power is equal to 1. So the only way for a 12 to become a 1 is if x is equal to 0. So x is equal to 0. That exponent has to be 0 in order for us to evaluate and get a 1. On number 17, 2 to what power is 64? Now this one's a little more complicated. 2 to what power is 64? Well, 2 to the fourth power is 16. 2 to the fifth power is 32. So 2 to the sixth power is 64. So x equals 6. Again, that's just using mental math. Number 18, 3 to what power is equal to 243. This one's even more complicated than number 17. Let's grab a calculator. Let's say 3 to the fourth power. What's 3 to the fourth power? Not quite there. 3 to the fifth power, 243. So x is equal to 5. Now, number 19 and number 20 are going to be very interesting. So number 19, we've got 9 to what power is equal to 1 over 81. Well, you know that 9 squared is equal to 81. How's the 81 going to end up in the bottom of a fraction? Well, the exponent, which is 2, is going to have to be negative because it means that you had to move the 81 down to the bottom. So negative exponents are going to indicate those fractions. On number 20, 64 to what power is 4? Now, this one's really difficult for me to explain here. Because to go from a 64 to a 4, I know I need a square root, or a cube root, or a fourth root, or a fifth root. So I tell you what, let me show you how to do this one in the calculator. in the calculator, the base on this is 64. We can't use that common log button in the calculator to evaluate this log. But there is a place where we can go to do that. If you go alpha zoom, just kidding, alpha window, alpha window. If you go to alpha window, number 5 says log base. So we're going to use number 5. We're going to pull up number 5. And what happens here is it gives you a spot to change that base. The base on this is 64, and we're taking the log of 4, and it should spit out, I don't want that decimal. I'm going to hit math, enter, enter to change it back to a fraction, which is 1/3. So x equals 1/3. Which means it was the cube root of 64. The cube root of 64 is 4. This next section, the change of base formula, is old school. This is old technology. Our newer calculators have the log base function on it, so we really don't need this change of base formula. Some logarithms are not as easy to evaluate as those above. Like on number 20, we totally could have used we could have used this change of base formula. And before this new technology was available, we had to use the change of base formula. So if we had log base b of a, we had to take the log of a, the common log of a, and divide by the common log of b. And that's your change of base formula. It's not that it's hard, but it's old, and we don't even need it anymore unless you have a very old calculator. So on this last section, it says to evaluate each log using the change of base. I'm telling you, we are not going to use the change of base formula. We're going to use the log base in the calculator. So go to, for number 21, we want log base 16 of 64. So we're going to go alpha window, choose number 5, log base 16 of 64, and we get 1.5. If you want to change that back to a fraction, math, enter, enter, changes it to 3/2. Number 22, log base 8 of 32, alpha window, number 5, log base 8 of 32, 32 gives me 1.6 repeating, math, enter, enter, let's change that back to a fraction, 5/3, and keep going. Number 23, log base 2 of 54, alpha window, number 5, log base 2 of 54. I don't think this one's going to change back to a fraction. It's not. So we're going to round this to the, let's keep 3 decimal places. So in this chapter, more is better. Let's keep 3. So I'm going to call this 5.755. 5.755. Number 24 says log base 10 of 294. Another way of writing this is log of 294. So I don't need log base. Log of 294, just using my button next to the 7 here because it's common log, 2.468. And last two, log base 4 of 136, alpha window, number 5, 4 of 136, gives me 3.544. And log base 6 of 1/36, alpha window, number 5, log base 6 of, I'm going to pull up a fraction, 1/36. This should be -2. And there are your notes for Unit 6, Chapter 12, Lesson number 1.